Hello everyone, this is the first lesson recording for IM2, January 28, 2021. We started off with doing the quiz number 2. So if you missed it for any reason, please contact me as soon as possible so that we can arrange your makeup. Then we went on to doing some warm-up problems. There are 5 pair deck factoring problems. So please pause the video and factor them yourself. The link will be in Canvas. Okay, let's go through this. Now remember, when you're factoring, the first thing you always look for is GCF. Okay, GCF is the easiest factoring, so you look for that. Now you look at the numbers. Are there anything I can take out? Number 3 and 12. We can take out 3. Okay, then 3 times what is negative 3x squared? Well, I can say it's negative x squared, but I forgot to do something. I did not check the variables, did I? So I need to go back and I look for variables as well. X squared and x, that means I can take out an x as well. So 3x times what is negative 3x squared? That's going to be negative x. And then 3x times what is 12x? That's plus 4. So now you have factored. Of course, you should be checking your answer by multiplying it back. How do I multiply it back? When you just have one term multiplied by a binomial, you can simply just do distributive property. And that comes out to be negative 3x squared plus 12x. And you should write your answers in the yellow box. Okay, second problem, x squared minus 11x plus 18. Now, we have 3 terms, but the coefficient is 1. That's the easiest type of factoring, because the only way you can get x squared is if you are multiplying some x plus something times x plus something. So I'm going to start by putting in my x's. And then I'm looking for 2 numbers that multiply to positive 18, but that add to negative 11. Okay, what are the 2 numbers? What are the factors of 18? Well, it's 1 and 18. If I add those 2 numbers, then I'm going to get 19. So that's not negative 11. What about 2 and 9? 2 and 9, if I add those 2 numbers, I get 11. So that's good. So it's going to be 2 and 9, but we want to add to negative 11. That means they both have to be negative. And as usual, you should multiply back using FOIL to check your answers. Okay, so how do I factor 8x squared plus 6x minus 35? I look for GCF first. Well, this one is only just constant, so that means I can't take any variables out, but I can look for numbers. Okay, so 8, 6, and 35. I do not see any numbers I can factor out. That means we're stuck with doing it the long way. So, unless we can see a perfect square trinomial pattern, the last term is not a perfect square, first term is certainly not a perfect square either. So, we have to do the diamond. And so we're looking for to put on the top of the diamond 8 times 35. That's going to be what? That's 280. And that's negative 280. And then we're looking for the sum to be 6. So again, I should be looking for my factors of 280. But I know one's going to be positive, one's going to be negative. So I'm looking for the difference between these 2 numbers, because when I add, it's going to be, one's going to be positive, one's going to be negative. So I'm looking for the difference to be 6. Okay, so I want difference to be 6, because one's going to be positive, one's going to be negative, or negative positive, we don't know. What are some factors? Well, 1 and 280, that's going to be obviously too big. 2 and 140, that's still too big. 3 and Is 280 divisible by 3? Okay, you just keep trying. What do you have? Well, 3 is not 280 is not divisible by 3. 4 is divisible. 4 times 70, but the difference between these two, 66. So huge number. Okay, so what about 5? 5 times what is, that's going to be 56. Still too big. 6 times, it's not divisible by 6. What about 7? 7 times 40. We're getting closer, but it's still way too big. 8 is not, 280 is not divisible by 8, and it's not divisible by 9. What about 10? 10 times 18. Okay, we're getting closer because the difference is now 8. What about 11? It's not divisible by 11. What about 12? It's not divisible by 12. And it's not divisible by 13 either, but it is divisible by 14, and that's 14 and 20. So I know that the solution to my diamond is 14 and 20. That means I am going to split the middle term into 14x and 20x. So that becomes 8x squared plus 6x minus 35 becomes 8x squared. So plus 14x. Oh, but we need to get positive 6x, right? So when you add those, we need to get positive. Why we forgot to put one of them negative signs here, because we know that one of them has to be negative. So that's going to be negative, and that's going to be positive, because we want the sum to be positive 6. So that's going to be minus 14x plus 20x minus 35. So then from here I put in my parentheses, and factor the first term, 8x squared minus 14x. I can factor out 2x because 8 and 14, they're both even. So 2x times what is 8x squared? That's 4x. 2x times what is negative 14x? That's going to be negative 7. Plus 20x minus 35. What can I take out? I can take out 5. And that leaves me with 4x minus 7. And I see that 4x minus 7, 4x minus 7 is, they're both factors to both the first half and the second half. So I take that out as a common factor, and you're left with 2x plus 5. Of course, if you're doing the area model, then you put the 8x squared here, and then minus 35 here, and then the solution to your diamond goes into each of the box, negative 14x and positive 20x, and then you look for your factors. Okay, and then you should get 2x plus 5 here. I'm sorry, I meant 4x, that's this one should be 4x minus 7. And this is 2x plus 5. Okay, next factoring. I have two terms only, and the first term is a perfect square because it's 1x squared, and 16 is a perfect square, and we're separated by a subtraction. That means it's a difference of square. So I start by putting my two parentheses. I take a square root of the first term. What is the first term square root of the first term? That's just x. So that's going to be x here and x here. What is the square root of the last term? That's just 4. So I put 4 here and 4 here. I know one's going to be positive, one's going to be negative. And as usual, you should use FOIL to multiply back to check your answers. Last factoring problem, 4x squared plus 20x plus 25. Well, I know that I do see that the first term is a perfect square, last term is also a perfect square. So there is a chance that it could be perfect square trinomial. So what do I need to do? I need to take a square root of 4x squared, that's the first term, which is 2x, and square root of the last term, that's 5. So then I multiply 2x by 5, and then multiply that by and double that. So 2x times 5 is 10x times 2 is 20x. And that's what I have in the middle term. Okay, so that means this, yes, I have just verified that this is a perfect square trinomial. That means I can put the square root of the first term, that's 2x plus 5, and it's got to be positive because this is positive. So this is positive. So that's going to be 2x plus 5, 2x plus 5, or you can just write 2x plus 5 all squared. Okay, so let's get to the main lesson for the day. What are we doing today? We're going to be finding attributes from both factored form and standard form, and just compare and contrast and make sure that we understand how to graph all of them. So to do that, we are going to be looking at, if you have a quadratic equation written in factored form, like y is equal to negative 0.5 multiplied by 2x minus 1 times 2x minus 7. Which attributes can I find out? Now, can you find out if this is a parabola that's going to be opening up or opening down? What about the vertex? Can you figure out the coordinate of the vertex? Can you figure out the line of symmetry, the equation for a line of symmetry, and the x-intercepts and the y-intercept? Well, the answer is yes. We can find them all. You can find the vertex pretty easily. You can figure out whether it's opening up or down. We know how to figure out the y-intercept and the line of symmetry and the x-intercept. So factored form is pretty handy there because we can easily find all of them. Well, it's not, sometimes not so easy. Sometimes the x-intercepts can be a little bit, well, if it's factored, it's always easy. Yes. So let's summarize what we should have learned already. Okay, these are all from previous lessons, so you do not have to take any notes. Just make sure that you understand all the steps. So if you are trying to find the x-intercepts of the quadratic equation, what do I do? Well, I know that x-intercept point always has a 0 as my y-coordinate, so that I can change the original equation and substitute for y to be 0. And then from here, using the zero product property, I can separate the two branches of the factors and set them to be equal to 0, because the only way I can get two factors to multiply to 0 is if either one or both are equal to 0. So then from here, I solve and get my two x-intercepts. What about the vertex from our last lesson? Since we know that they're always symmetrical, if you know the two coordinates of the x-intercepts that are easily found, then what you need to do is take an average of those two x-intercepts, because the x-coordinate of the vertex is always going to be in the middle. So in this case, 3 plus 1 divided by 2, which is 2. And then to find the y-coordinate of the vertex, you need to substitute the value that you just found, x is equal to 2, to your original equation to figure out what the y value is when x is equal to 2, and so the vertex is 2, negative 1. And the y-intercept, you just need to substitute the fact that x coordinate is going to be 0 into the equation, and then figure out the y value.